So now let's do some mapping. So I'm going to show you how to acquire a 3-window map and a 2-window map. So an elemental map and a jump ratio map. So we're still in the EFTEM technique. So all of the mapping functionality is in the bottom row of this EFTEM palette. So actually the first thing that we should do is a thickness map. So we need to see if the area is thin enough for analysis. So let's go ahead and do the thickness map. I'm gonna hit thickness map. I'm gonna leave the filter parameters as they are, so 0 and 10 EV. Let's leave it at binning 2, auto exposure, capture. So the thickness map is just the log ratio of an unfiltered image and a zero loss image. So we're acquiring an elastic image, an unfiltered image, and then we get the thickness map. You can right click, pull up the toolbar menu. Let's look at the line profile over this region. So it looks good. If I increase the integration width with the plus key, we can see that everything's mostly kind of around 1 T over lambda, or just under, which is great. So now we want to acquire our filtered image. So let's start off with the 3-window. The 3-window map. So I hit 3-window. We were already on nitrogen. But if we want to change the element that we're mapping, we just use the periodic table here. Nitrogen, see? So there's predefined slit widths and energy positions for all of the elements already. Generally, the widths here when we're doing elemental mapping are a lot wider. So you can see that for nitrogen, it's 30 EV. Obviously, we need 3 windows because it's a 3-window map. So we have our pre-edge 1, pre-edge 2, and our post-edge. Kind of general rule of thumb is as you go to higher energy, those slit widths are going to get wider. So if I show you copper, for example, the width there is 40 because we have less electrons at higher energy loss, so we need a bigger slit width to have decent signal. So let's go back to nitrogen. Now let's move on to the detector parameters. So it's core loss, so we want to have binning of 4x or 8x. So I'm going to go with 4, auto exposure, and let's go and capture. So we have post edge, pre-edge 2, pre-edge 1. Okay, so the cross correlation kind of minimum threshold is 0.3. So the software's asked us if we want to go and do a manual drift correction. I'm just going to accept this drift correction for now. The sample's been in the microscope for a while, and I know it's stable, so it's just kind of a signal issue here. We're going to cover this actually in one of the computing labs, how to do the manual alignment, so we'll skip it for now. Accept. Okay, so there's our first nitrogen map. So that's our 3-window map. I'll go ahead and grab a 2-window map. Looks pretty similar, but here we just have pre-edge and post-edge parameters. So again, you can use the periodic table, select your element, and then hit capture. So everything's the same, hit capture. Don't put it there, Paolo. That's in the field of view of the camera. Like, it's a super wide lens. I'll have to mute myself now. It's fine. Okay, so I'll move that into the other workspace, so multi-map 13 or 14. And then, whoopsie, multi-map 13. So, okay, so you can see the two maps. So the jump ratio at the bottom and the elemental at the top. So let's just do a little quick comparison. If we draw a line profile across the center of this region here, and then let's do something similar over here. There we go. So if you look in terms of absolute numbers, the numbers that we get from the 3-window map are kind of extracted intensities, so values in count. So we're going to go from 0, where there's no nitrogen, to something that's non-zero, where there's nitrogen. So the intensity in this image is like directly proportional to the amount of nitrogen that we have, whereas the ratio is a bit different. So you can kind of see that the 0 point is just some arbitrary number. So it's just a ratio. We're dividing one image by the other. So the baseline here seems to be around 0.75. And we just get a kind of an increase in the ratio where the nitrogen is. So we're kind of looking at some values between 0.75 and 1. So these aren't quantitative values in the ratio image. Kind of some of the pluses of the ratio image: it suppresses diffraction contrast. But yeah, again, we're going to cover this in much more detail in one of the processing labs that's about to follow this lesson. So I'll leave it at that for now.